All right, if you're getting ready for that GCSE Chemistry exam, then you have come to the right place. We're going to build your ultimate survival kit today, and we are starting with the foundation, the absolute bedrock of, well, all of chemistry really, the simple model of the atom. Let's do this.
So you might be asking, why the atom? I mean, it's supposed to be simple, right? Well, here's the thing. This is exactly where so many students stumble and just needlessly lose marks. But that's not going to be you. Not after today. We're going to turn this common hurdle into your secret weapon.
Look, this isn't about just memorizing facts from a textbook. No way. This is about getting inside the examiner's head. It's about figuring out what they're really checking for. So come on, let's pull back the curtain and see what's on their secret checklist. Okay, here it is. These 4 points, this is the whole game, right here. The examiners are just checking a few simple things. Do you know what's in the nucleus? Do you know where the electrons are? And do you know the charge for each little particle? If you can nail these basics, you are golden. But, and this is a big but, if you get these confused, it's like a domino effect. You'll see mistakes pop up all over your paper. We don't want that.
But hey, don't worry, don't sweat it, because we're about to crack this whole thing wide open with just one simple, powerful sentence. This is the key that unlocks everything.
This is it. This is the sentence. I want you to burn this into your brain, seriously. Almost every single question you'll get on atomic structure comes back to this one idea. The nucleus, small, dense, positive. The electrons on the outside, and negative. You get that? You've already won half the battle. Okay, so now that we've got the big picture, let's zoom in. Let's get to know the main players here, the atom's little all-star cast. We're going to break down the 3 subatomic particles you absolutely 100% have to know.
First on the list, the proton. And here's an easy way to remember it. P for proton is P for positive. It's also P for parked right inside the nucleus. So it's a positive particle, and its home is the nucleus. Simple, right?
All right, next up is the neutron. And honestly, this one's the easiest of the bunch. Just think, N for neutron is N for neutral. It has no charge at all. And just like its buddy, the proton, it also lives inside the nucleus.
And finally, we've got the electron. Now this is the real live wire of the atom. It's always moving, always doing something. It's got a negative charge, and you'll find it zipping around outside the nucleus in these specific paths or energy levels that we call shells. So let's just recap with this table. Think of it as your ultimate cheat sheet. You've got your protons and neutrons chilling in the nucleus. Electrons are buzzing around on the outside. And the charges? Positive, neutral, negative. That's it. Location and charge. That is the whole story in a nutshell. Okay, so this brings up a really important question. If we have all these positive and negative charges flying around, how come the atom itself is neutral? Well, it all comes down to balance. It's beautifully simple, actually. For every single positive proton in the middle, there's one negative electron on the outside to cancel it out. It's a perfect one-to-one match. So the overall charge? 0. Nada.
All right, now it's time to become a code breaker. See, every element on that periodic table has these 2 little numbers next to it. And those numbers, they're like a map to a treasure trove of easy marks on your exam. Let's figure out how to read that map.
Okay, listen up, because this is a super common trap students fall into. You've got the atomic number and the mass number. The atomic number is just the number of protons. That's it. The mass number, on the other hand, is the total count of protons and neutrons together. A simple way to remember? The mass number is always the massive number. It's bigger, because it's counting 2 things.
And hey, want to know how to grab some really easy marks? Examiners love to ask this. To find out how many neutrons an atom has, you just do a tiny bit of subtraction. Take the big number, the mass number, and subtract the small number, the atomic number. The answer is your number of neutrons. It's basically a free point. It's a gift. Don't leave it behind.
So, we've spent a lot of time talking about the nucleus, right? The core of the atom. But now it's time for the main event. Because when you get right down to it, all of chemistry, it happens because of the electrons. They are the real rock stars of this whole show. So these electrons, they live in these shells around the nucleus, and each shell can only hold a certain number. The first shell, the one closest to the center, it's pretty small. It can only hold a maximum of 2 electrons. That's it.
And once that first shell is full with its 2 electrons, any more have to go into the next one out. That's the second shell. It's a bit bigger, so it can hold up to 8 electrons.
And then for the third shell, well, for what you need to know for GCSE, it also holds a maximum of 8. So the rule is super simple. You just fill them up from the inside out. 2 in the first shell, then 8, then 8. Just remember that pattern. 2, 8, 8.
I'm going to say it again. In chemistry, it is all about the electrons. Think about it. Bonding, chemical reactions, how reactive an element is. Every single one of those things comes down to the electrons, and specifically the ones in the very outermost shell. We call those the valence electrons, and they are the absolute VIPs. If you get how they're arranged, you're ready to understand, well, pretty much everything.
Okay, let's bring this all home. Why have we spent all this time obsessing over these tiny little particles? What's the big deal? It's because the atom isn't just another topic on a checklist. It is the foundation. Everything else in chemistry is built right on top of this knowledge.
I mean, just look at this stuff. Ionic bonding, that's all about giving and taking electrons. Covalent bonding, that's about sharing electrons. The whole periodic table is just organized based on atomic structure. If you're shaky on this stuff, it's not just one question you'll get wrong. It'll cause problems everywhere, especially on those big, juicy 4, 5, even 6-mark questions. You need this foundation to be solid.
All right, let's do a quick self-check right now. Can you, without pausing, tell me the difference between the atomic number and the mass number? Can you tell me the charge and location of a proton, a neutron, and an electron? If the answer is yes, if you can do that confidently, then you're not just ready for this exam, you are ready to absolutely smash it.
So please, don't think of this as just ticking a box for a topic. This is the beginning. The atom is the fundamental Lego brick of the entire universe, and you now have the instruction manual. You have the blueprint. So the only real question left is, what are you going to build with it?